Okay, so this problem tends to be a problem that throws a wrench in some people's train of thought, only because I think it's just because we see cosines and sines, we see some trigonometric functions, but hopefully we recognize that these are sinusoidal, and if we expect anything to expand in some form of a curve, anything that's not going to be linear, anything that doesn't have any kind of symmetry that is linear, we expect it to expand in a way that is not consistent with just a sine function. I'm sorry, just with a linear function. So if we look at this question, we have two offshore oil wells are located 200 meters apart, and they begin to leak at a certain time distance t equals to 0. So I like to draw pictures. I think that really helps me. It lets me think a lot. So if I have oil well 1, I'll call that oil well 1 and oil well 2. I recognize between these two oil wells, I have a distance of 200 feet. So between these two wells they're located 200 meters apart. They begin to both leak at a time t equals to 0. So now we want to assume that the oil spills are in the shape of circles. So the oil spill starts here and it's leaking, and then it's going to expand more, and it's going to leak even more. And it's going to expand more, it's going to leak even more. So it's going to be expanding in this circular notion, and the same thing's happening over here. It's going to expand, it's going to keep expanding, it's going to keep expanding. So ultimately, these oil spills will expand and expand and expand and expand and expand in a circular form. It says that well number one's oil spill has a radius at any given time. So the radius of the oil spill, it could be at this value r here, or it could be another value r here, or it could be another value r here. This radius could exist all the way out, does not matter, but it's going to always expand in the form of 2t squared plus 5 over pi, cosine of pi t's minus 3 over pi sine of pi t's minus 8t minus 5. So it gives us the definition, gives us how to calculate the radius of oil spill 1. And then it also gives us the radius of oil spill 2. So the first portion says that we have to compute the time instance at which the two spills merge. The two spills merge. They touch each other. So let's go ahead. I'm going to draw this oil spill. I'm going to keep this in red. As this oil spill goes out further and further and further, I'll say it expands right about here. So this value is an equal to my R1. Okay, so now over here, as this guy expands, let's assume that he expanded out circularly and they just touched. And from here to here, we know this to be a value of R2. So let's look at this. We know the total distance between here to here is 200 feet, and from here to here is R1, and from here to here is R2. Can you see a way in part A for us to relate R1 and R2 to our value of 200? And hopefully we recognize that R1 plus R2 equals to a value of 200 feet. R1 plus R2 is equal to a value of 200 feet. This from here to here plus this from here to here, R1 plus R2 equals the total distance of 200. So we're just going to plug in. R1 in terms of t is going to be equal to 2t squared plus 5 all over pi cosine of pi t minus 3 all over pi sine of pi t minus 8t minus 5, which is our value of R1. This is just our value of R1. So R1, which I got directly from the problem, plus R2, which is going to be 3t squared minus 5 all over pi cosine of pi t plus 3 all over pi sine of pi t minus 7t plus 5, and this is still equal to a value of 200. That is still equal to a value of 200. So we have now gone ahead and added in our values of R1 and R2 in terms of pi's and t's and their functions. So notice here, 5 over pi cosine pi t cancels with negative 5 over pi cosine pi t. Negative 3 over pi sine pi t cancels with 3 over pi sine of pi t. So we're going to be left with 2t squared. Here we're going to have minus 8t minus 7t, which gives us negative 15t. And here we're going to have minus 5 plus 5 cancels. Oh, and I still have my value of 3t squared. So I still have 3t squared. I didn't see that there. So my 3t squared, and this equals a value of 200. Make sure I do that correctly. Minus 8t minus 7t gives you minus 15t. Okay, perfect. So we're on the right track. 2t squared plus 3t squared gives me 5t squared minus 15t equals to a value of 200. I'm going to divide out a value of 5 straight across the board. It makes it a little bit easier to work with. So this will give me t squared minus 15 divided by 5 gives you a value of 3t. 20 divided by 5 gives you a value of 4. Add the 0 gives you a value of 40. And in order to solve this quadratic, we have to make sure it's set equal to 0. So we're going to have t squared minus 3t minus 40 is equal to 0. Factoring this guy out or using the quadratic formula any which way you so find acceptable, you're going to have t and a t. Our first sign will be negative, and what times a negative gives you a negative? That will be positive. Factors of 40 that give you negative 3 are negative 8 and positive 5. Setting both of these equal to 0, we get t is equal to 8 and t is equal to negative 5. And t is a term of time. It's in hours. So clearly the only answer we can have is when t is equal to a value of 8. Therefore, we know that the specific time at the instance when these two spill merge will be exactly at 8 hours after the release of the first droplet of oil. Now moving on to part B. Compute the rate, notice rate, we're thinking derivative, of which the radius of spill 1 is changing at this time. Is the radius increasing or decreasing? So it wants to find a rate of spill 1. In order for us to find the rate of spill 1, we're going to have to take the derivative of spill 1. So we're going to have to take the derivative of spill 1. Let's go ahead and do such. So here we're going to find the derivative of spill 1. Spill 1 was r prime of 1 in terms of t is equal to derivative 2t squared gives you a value of 4t. Derivative of 5 over pi, I'm going to keep that out here as a constant. Derivative of cosine is negative sine of pi t times derivative of the inside. Remember, pi is just a constant. Derivative of pi times t just gives you a value of pi. Derivative of pi t, pi is a constant, 3.14 is a constant. It's just going to be a value of pi minus 3 all over pi. Derivative of sine gives you cosine of pi t. Derivative of pi t, remember pi is just a constant, so we're just going to have a value of pi, perfect. Minus derivative of at gives you value of minus 8. And we still have the derivative of negative 5, which is just a value of 0. That's just a constant. So we are good to go. Let us notice pi here cancels with pi here. Pi here cancels with a pi here. So this actually simplifies out very nicely. R prime of 1 in terms of t is equal to 4t plus 5 times the negative. So this actually becomes, and I should have actually emphasized here, this should be times. So we didn't miss that. So this should be 5 times the negative gives you minus 5 sine of pi t minus 5 sine of pi t minus 3 cosine of pi times t minus 8. So that's what this derivative simplifies down to. Nothing too bad. But we want to know the derivative at one specific instance, and that was at the instance in which the two oil spills touch. So we know they touch when t is equal to 8. So everywhere we have a t, we're going to have to plug into 8. So we're going to have 4 times 8 minus 5 times sine of 8 pi. T was equal to 8, so we have 8 pi minus 3 cosine of 8 pi minus 8. Let us keep working. 4 times 8 gives you a value of 32. Let's look at our sine curve. Our sine curve looks something like this. 0, 2 pi. Keep going. This will be at, I'm sorry, this is pi, this is 2 pi, this is 3 pi, this is 4 pi, this continues on. Sine of any value of pi such that pi is an integer is always going to give you a value of 0. If we go down all the way down here to 8 pi, we're going to have a function comes up like this, so it's going to be 0. Therefore, this guy all goes to 0. Be very careful with cosine. If we look at our cosine curve, drawing it out, here at 0, again this will occur at 2 pi. This will occur at 4 pi. Notice at every value of n pi, where n is an even integer, we know cosine is equal to what value? So this would all be down here at 8 pi. It would be equal to a value of 1. So this goes to a value of 1. 1 times 3. So here, well, 4 times 8 is 32. Minus 0 minus 3 times 1 gives you minus 3. Minus 8. 32 minus 3 gives you a value of 29. 29 minus 8 gives you a value of 21. And this is my radius derivative, which will be, I believe the units there will be meters per hour. So derivative will be meters per hour. And notice the sign of this derivative is what kind of value? A positive value. Since the sign is positive, we know that this is increasing at that time. But that makes sense. That we expect our oil spill to get larger and larger and larger and larger. We don't expect it to stop and all of a sudden start getting more negative and smaller. We expect that our rate is going to be indicative of the radius, and since our rate is positive, we know our radius is getting larger.